So one of our methods for finding extreme values is called the candidates test. Uh, this is a great test for finding absolute extrema since it is a relatively quick method. Drawback: this only works for absolute extrema on a continuous function on a closed interval. In other words, this is specifically working with the EVT, the extreme value theorem. So what we do with this is we find the function values at the endpoints because we're continuous on a closed domain. We find where the function's derivative is 0 or undefined, the critical points. We find the function values at those critical points, and then from this list of function values, the largest is the absolute max and the smallest is the absolute min. It sounds like it should be more work than that, but because the EVT guarantees an extreme value, that absolute extrema must exist, both an absolute max and an absolute min, if we can, we don't need to check increasing and decreasing. If we find all of the function values where extrema could occur, one of them has to be the absolute max and one of them has to be the absolute min. So doing this in action here. So this should say, so sorry with my typos, this should be e to the x cosine of x. So we're considering the function defined by e to the x cosine of x on the domain 0 to 2 pi. That is a closed interval. E to the x is continuous, cosine of x is continuous, so the product of them is also continuous. So the EVT does apply. So since the EVT applies, I can do the candidates test. So I need to know the function values at the endpoints. So I need to know f of 0, which would be e to the 0 times cosine of 0. Now e to the 0 is 1, cosine of 0 is 1, so that's 1. F of 2 pi would be e to the 2 pi times the cosine of 2 pi. I have no idea what e to the 2 pi is, but the cosine of 2 pi is 1, so this is going to be e to the 2 pi, which I know is going to be bigger than 1. So those are my endpoints. But now I need my critical points, or you'll see these abbreviated CP a lot. For that, I need the derivative, f prime of x. So I'm going to need the product rule. So I have first times the derivative of the second plus second times the derivative of the first. And I'm going to go ahead and factor the e to the x out. And I want to know, where is this equal to 0? And where is this undefined? Well, e to the x is never undefined, cosine of x is never undefined, sine of x is never undefined, so the whole product and difference of these is never undefined, so the undefined part is easy. For equal to 0, I factor this because e to the x can never actually equal 0. There's no value of x that I could raise e to get 0. So that means cosine of x must minus sine of x is the part that has to equal 0, which means cosine of x equals sine of x. And from 0 to 2 pi, there are only two angles where that happens. It happens at pi over 4, and it happens at 5 pi over 4. So this means I have two critical points. So I need to know what are the y values at f of 4 pi over 4 and f of 5 pi over 4. The reason I only looked from 0 to 2 pi is that was my domain. So for pi over 4, I have e to the pi over 4 times the cosine of pi over 4. Well, the cosine of pi over 4 is rad 2 over 2 times whatever e to the pi over 4 is. And then e to the 5 pi over 4 times the cosine of 5 pi over 4. Well, the cosine of 5 pi over 4 is negative rad 2 over 2 times e to the pi over 4. So what I have are four different y values. And so my absolute minimum is either going to be 1 e to the 2 pi rad 2 over 2 times e to the pi over 4, negative rad 2 over 2 times e to the pi over 4. Well, the smallest of those is the only negative value. So right here tells me that my absolute minimum is the negative rad 2 over 2 times e to the pi over 4, and it occurs at x equals 5 pi over 4. For the absolute maximum, well, I know e to the 2 pi is bigger than 1. I am not certain about what rad 2 over 2 is smaller than 1, which means that multiplying that by e to the pi over 4 is smaller than e to the pi over 4, which is definitely smaller than e to the 2 pi. So here tells me that my absolute maximum is e to the 2 pi at x equals 2 pi. And that's how we find our absolute extrema with the candidates test.